This is Vic Smead's book on model boating. Vic Smead was a British model engineer. He designed lots of boats. Anyway, in this book on steam engines, chapter 11, he has this little diagram here of a vertical oscillating steam engine that can power boats from 24 to 30 inches. A lot of little details that are left out, but I think you could make an engine from this. Okay, we're back out in the shop today. It's a little chilly outside, but the sun's out and I've got the fire going in the shop. Plan today is to solder up the cylinders to the cylinder block. I've got two of these made up. It goes like this. Of course, this will have two holes in it, three holes in it. One for the pivot pin and one for the exhaust and intake. And this one will have one hole drilled in it for the steam to come into the top of the cylinder. That hole will go all the way through. This one was a leftover cylinder from one of my BizWiz steam car engines here that I cut down. And this one actually is the bore is a Y drill, which is .4040 4040. It's a little bit bigger than this spacer that I got at Lowe's was 3/8 half-inch OD, 3/8 ID. I think that'll be fine. Old bathtub faucet. I cut a piston for the larger diameter. It's all brass. Of course, that's got a hole in it. I'm going to thread that 540 because I'm going to make the connecting rod's going to be at 1/8 inch steel, and 540 works well with 1/8 inch rod, 540 thread. I've got the die, taps and dies for that. The cylinder has to have a cap. You have to block the top of the cylinder on that. It's just a little piece of brass. I've got some solder, acid core metal repair solder. I don't know where I got that. And then I've got some Linux paste flux. I've used this in the past. It works okay. I have a Sievert. They're like the big name in nice torches. Sievert. And a barbecue can of propane. That's what I'm going to use to solder this. You could just use a butane Bernzomatic torch. And I'm over here at the 1941 South Bend 9-inch lathe, and to make this little wobbler steam engine I had a piece of steel tubing. Just to make things hard on myself, I use scrap. It's cheap, but it does require more work, and this has an odd inner diameter, about 40/40. So I made a piston for it out of brass. Supposed to be a half-inch piston according to the drawing. And I want it to fit. If you have a steam engine that has any power at all or runs at low PSI, you want that fit piston to the sleeve cylinder. You want the fit to be tight. The length of the cylinder, the inner diameter of your cylinder has to be round. And it has to be smooth and uniform. Otherwise you're going to lose compression. And that's what a ring does. But these are really small, and it's hard to make a ring. I mean, you could use one of those green O-rings. If you hone this out smooth and uniform and round, you won't need a ring. A lot of small steam engines, they will machine a little 50 thou groove. It's called an oil groove. And you'll see that, you even see that on a lot of older piston engines, model engines. It's called the oil groove. The idea is this little ring traps the oil and makes a seal with the cylinder, but your cylinder's got to be uniform. In order to get this cylinder uniform, what you can do is to hone it. And for a hone this small, I mean, a lot of guys make them, machine the diameter close, and then you split it, and then you put a screw in the end. I'll show you what I mean. Now this is actually an expandable mandrel. Now these are to put in a pipe or a tube. You expand it, then you can use this. You can clamp this in the jaw and turn your piece. Instead, what I've adopted is to use these expandable mandrels, and they come in a set, and they're not very expensive. I mean, this was one of those Harbor Freight deals, you know, $35 or something. I got a whole slew of them. I mean, the expandable mandrels come in handy if you're doing machine work anyway. And the only trouble is this is an odd size. It's not 3/8. It does have a 3/8 inch mandrel. Now you can make these. They're pretty easy. You know, you just you machine the OD to the size you need, and then you put a couple slits in here. You can just cut it with a saw so that it expands this way. You can put 4 slits in it, and then you put a screw in there. And as you drive the screw in, you thread it, and as you drive the screw in, it expands the mandrel a little bit. So what you could do is just take some fine valve grinding compound. Lopping compound comes in like white and gray, or light and dark. The fine is the lighter. If you really want to get down to brass tacks, you can use Bon Ami toothpaste because it had a fine grit in there. Put the valve lapping compound on here, chuck this up in the lathe, and get this exact. So I don't have one of these that'll fit. So what I've decided to do is just have a piece of scrap metal. But again, you run into the problem using scrap, you get odd sizes. And I'm going to make this mandrel, I'm going to make it exactly the size, slightly larger, a couple of thou larger, and I'm going to hone this cylinder out for a perfect fit for my piston. One of the problems that you run into when you want to make a perfect piece, I don't know if you can see this, but there's little rings here, there's irregularities. I used a kind of a round nose tool that was pretty sharp. I rounded it to get a smooth cut. But every time when you're turning the hand wheel and the tool's cutting across your material, every time you hesitate, the chuck keeps spinning, you hesitate. So the rate of travel of your carriage, the rate of travel of the tool across the metal changes. And that changes how many times the tool cuts in a certain area. So a lot of people will use 2 hands on the hand wheel to try to keep it rolling at a steady rate so that you get the smoothest cut. The only chance, even when you change from one hand to the next, you can see this is every so often there's a little ring where I changed hands. So they came up with a cool feature, and that is the self-driven carriage, which this lathe has. Early automation, I guess. So I'll show you how it works. It has a clutch to engage and disengage the self-travel, and then it has the forward and reverse gears here. I have it in forward now. Forward is towards the headstock. I have it in forward. And then you have your speed. You can set the speed. This is for threading. It was originally designed for threading. You can set the speed of the screw here to get your threads per inch. But you can also use, if you set it at a fairly slow speed, cut a very smooth diameter in uniform, you can use the same mechanism. So you see the lead screw spinning. Engage the clutch. Look at that. Now it'll also, with this clutch here and this gear changer, you can move the cross slide with that, and that comes in handy on certain applications. So I'm going to move this up, and we're going to cut using that speed. I've already set the speed that I want for a smooth cut, and you'll see that there won't be any of these little these little rings. It'll all be uniform. I just have to watch it. I have my stop set so I don't cut my jaw off. You can machine your jaw right off. This machine will just keep going until it, and usually the belt will fall off, or something. It'll just stop. It'll quit. Belt will spin. Could theoretically on a big machine you could machine your jaw off. You could break something very seriously. So you have to remain vigilant. So here comes the power. Now I think you can see how perfectly uniform that is now. And what I'll do is I have the clutch out and I'll finish up the last little bit. I took too big of a cut. And now I'm going to use the change gear. Now this is the same tool that you use to lock the carriage. And I'll pull this through a little bit with the belt to make sure I engage the gears. Tighten it back up. Close the cover. I'm going to leave the cutter at the same setting and then just reverse it. Very uniform. I'm going to finish this up. I'll file it and polish it with some sandpaper, maybe 320 grit sandpaper. And then I'm going to take it out of the chuck, reverse it, put the cylinder in the chuck, put this in the drill, and then run it in there at a fairly high speed with some polishing compound, some white polishing compound. Bring the cylinder into a real nice smooth inner diameter. So I've got the mandrel all made. What I'm going to do is put a little bit of valve compound on there and just run it in while I'm spinning the cylinder. You want to be extra careful. You don't want to get any of this compound on any of the working parts of your lathe. It's designed to grind. It can damage your lathe. So just use a little bit on here. All you do. Now if you had an expandable, mandrel, turn the screw in a little bit and open these up and do it again. I don't want any of this stuff on my lathe. I have the cylinder and I want to clean it out and inspect it. So I have a little jeweler's loupe. This is a 10X jeweler's loupe. I have a little jar of kerosene. I want to clean this out real well and then inspect it with the jeweler's loupe to see if I need to do a little more. You hold it up to a light, kind of like when you're cleaning your 22 and you hold it up to the light after you run the cloth through it a few times to see if it's clean. Well, I'm going to look in here for scratches, defects, irregularities. You can also take the piston and test it a little bit. Piston should slide through there, and as you can see it doesn't, but you can slide the piston through and then hold it. If you hold your finger on it, it'll stop it, like when you stop water from going through a straw. So you can see that piston's catching on something in there. I need to do a little more honing. Yeah. catching. I can see the roughness. So I'm going to go back, hone it a little bit more. We'll do that off camera. Alright. I've got the cylinders cleaned with denatured alcohol. I've got them coated with a little tiny bit of paste flux. Where your flux is where your solder is going to go. So if you don't want solder all over the place, don't put flux all over the place. Just put it where you need it. So I'll zoom in. I'm going to light up the torch. Perfect. So I've got the torch going. I needed a positive way to hold these, clamp them, little clamps. That's one. Alright, let that cool. Okay, the next step is to solder the valve plate to the frame on both. I've got two of those all made, and I notched that out like a 10 thousandths, so it will be square on there. It just rests like that. Got to solder these bearings in these holes. I'm going to solder those with the crankcase, the crankshaft in place. So now I'm going to solder the bearings in, clean, fluxed, and in place where I want them. And I've got a 1/8 inch shaft is in there to hold everything in good alignment. So this solder is so thick that it's just going to leave a big blob on there. So I got this really tiny stuff, 0.32 diameter. So hopefully it won't make a mess. Put a wee bit more in there. That looks better. Where's it going? Oh, there it goes. Coming out the other side. Alright, now I'm going to put the valve plate on the frame. And I've sketched a little tiny center line on it so it lines up with the center line of the crankshaft and the overall frame. I'm going to solder that on now. Just trying to figure the best angle to get this solder to flow properly, and I think it's going to be just like this. Use my little machinist clamps again. They really help. Alright, I went and got my sparker. Looks pretty good. It's on there pretty good. The solder penetrated all the way up, all the way around. So I'm happy with that. That's where we are so far. The cylinder is finished, cooled down. The cylinder will go right here like this. The cylinder cap. It's a little brass cap for the cylinder. Go in there like that. So it's starting to look like something. Look at that.